Okay, let's keep going. Gotta keep practicing. Not sure what for, but we gotta keep practicing. Alright, let's go ahead and see what we got today. Hopefully something good. I'm hoping for more sort of unique tree or graph questions. Alright. Strictly increasing or decreasing. Given the list of items, return whether the list is strictly increasing or strictly decreasing. Okay, what I'll do here is Flexport Bay Area startup in Google. Jeez. So, we're gonna keep 2 Boolean flags. One Boolean for increasing, Boolean for decreasing. And we're pretty much just going to iterate once through the list. And we just update them. And then we return pretty much if either one of those remains true. So let's do Boolean is increasing and Boolean is decreasing, false. What we're going to do then is to iterate through the list is less than nums.length. This time we're going to do -2 because we need to not go out of bounds with the last element. Alright, I think that should be the setup that we need pretty much to do everything for it. And then we're going to basically say is increasing equals is increasing and nums at I plus 1 greater than nums at I. There we go. And then we're going to do the same thing for decreasing. +1, but this time it's going to be less than. And then at the end we can return is increasing or is decreasing. I think this is where the Boolean algebra aspect comes into very handy, because looking at this, if at any point this becomes false, this entire statement will be false for both of them for the whole time. What I think might be also a time save. Let's go ahead and run this and see if it works. If it works, I have a bit of an optimization. Why doesn't that work? Wait, oh, why did I want to declare this as false? Should also always be declared as true at the beginning. That works. 0 and 0 does not work. Okay, but this should still work. Why doesn't it work? I think it might be a thing with two-sized lists. What if we start the list at 1 and we just go to the end, and we just do I here, and then we just do a -1 here. There you go. See, that still works, but this one doesn't work. What I can do also is to say, I want to check something. Do we ever hit this list? We do not, that's why. So, what I think we should do here is to say, if nums.length equals 2, and nums at 0 does not equal nums at 1, then we can also return true. This, I think, needs to be its own conditional, though. Here we go. Do this. Then we return true. Otherwise, return false. Because if they're not the same value, then the list is going to obviously be either decreasing or increasing, one or the other. That should fix that edge case. And I think yep, okay, so strange that the result here is still true. I guess one thing we can do is also say if nums at I equals nums I minus 1, we always return false because it's neither increasing or decreasing than that list. And I hate these edge cases so much. So we go into the list twice, right? We go here, check. Go here and check. So this check, right, should keep is increasing true, but is decreasing false. So let's go ahead. I want to do one thing instead of just logging that. What I want to do is log. Ooh, okay. V, not B. There you go. So is increasing is going to be equal to plus is increasing, and to log is decreasing as well. Cool. So let's see what we get after this. See, this is what I don't understand now as to, because if it's decreasing, oh, oh my, you're joking. Is this just it? That makes so much more sense as to why that just was not working. Great, now let's go ahead and see if this takes care of that. Cool, we can, I think, even get rid of this edge case maybe. Cool. So yeah, that logic was there. It was just me being dumb and not, not putting in the correct variable in the correct place. Because, I mean, if you don't update the correct variables, obviously you're always going to get the wrong result. Okay, let's see what we got next. Consecutive duplicates. Given a string S consisting of X and Y, delete the minimum number of characters such that There's no consecutive X and no consecutive Y. So I think for this one, what we need to do is we don't really care about which characters we delete is the thing. So all we need to do is every time we change character, we add that character, new string, always keep track of cur. When character does not equal cur, we perform the above operations. Okay, let's go ahead and try it. So, car cur. Let's first of all make a string builder. God, I love using string builders. I think in my Microsoft interview, they actually came in super handy. Because the person interviewing me actually brought them up. Car C, car cur equals the s dot char at, not s, s dot char at 0. We're also going to add current to our string builder. From yesterday or 2 days before, I saw a good solution to understand it better. So, we're going to add this to the string builder. For car C in s.toChar array, let's go ahead and break this up. Oh, caps lock, caps lock. If C does not equal cur, alright, so if C does not equal cur, what we're going to do in this case is update cur. Cur equals C, add C to the string. Add this new cur, and I think that's legit all that we do. And we return the s.toString. What am I doing wrong? Oh, cur equals. It's not add, it's append every time. I always end up getting that one wrong somehow. Cool. Ooh. So this edge case, hey Maxflow, welcome. Ready to speedrun through everything again? Alright, so if s.length is equal to 0, we just return an empty string. Cool. Easy. Largest sublist sum. Given a list of integers nums, return the sum of a non-empty contiguous sublist with the largest sum. Okay. So, kind of curious. Divide and conquer greedy with prefix sum. Okay. Okay, I've solved something very, very similar. Let me see what the fourth problem is and just see which one of these I want to tackle. Number of k-length sublists with average of at least target. They're both prefix sum. Okay. Okay, so here is what we're going to do. Prefix sum immediately makes me think of a map. So let's go ahead and start writing this out because this problem is well outside of my comfort zone. So this is going to be kind of an actual sort of challenge. Let's see. So prefix sum equals hash map most of the time, right? What exactly can we store here? We can store because prefix sum is DP. Is DP as well. So at any point, what I think we would like to know, we need to store the sum from element A to element B, so that if, let's say, we have A, B, C, we can look at C plus that sum that we've stored up earlier. The obvious brute force way to do this is an n squared, which seems very, very bad. And we don't want to do that. I think potentially, because it's a contiguous sum, no, that wouldn't work. I was going to say we could store the sum from, let's say, the sum of, so maybe not in a hash, if we store an array with the sum of its and all previous elements, right? So we sum up the array, so it'd be, for example, 10, the next one would be 10 plus negative 5, the next one would be 10 plus negative 5 plus 12, and so on and so forth. Then we can always have a reference of what the remainder of the array sum is starting from that point. And then, potentially, we could traverse from the right side. And by traversing from the right side, we can see, hey, does this make the array sum, does keeping this make it smaller? If it does, we remove it, and we keep going until we find something that does not make it smaller. Because, for example, right, we can start at 20, and we can go to negative 1. Well, no, that does not work still, because the sum from 100, from 3 to negative... Oh, goodness, I hate prefix sum so much. I hate anything to do with, like, memorization and DP. What's the hint? What is the maximum sum that I can obtain till this index? Index as in the end. I'll just fix the typo. Cadanes. What is cadanes? Let's see what that is. Let's do a bit of research and do a bit of learning here. So, Cadane's algorithm is an iterative dynamic programming algorithm. It calculates the maximum sum subarray ending at a particular position by using variable cursum. Wait, okay, by using the maximum sum subarray. Here, let's go ahead and read through this article. Because if I can actually get a hang of this algorithm, it'd be pretty great. Okay. Given an array of integers, it has to find the maximum subarray sum possible, all the not-empty subarrays. Simple. Yep, you just loop. That's the trivial one. Okay, define two variables, cursum, which stores the maximum sum ending here, and maxsum, which stores the maximum sum so far. This is like, wait, this is sort of similar to knapsack, I think, in the way that the algorithm is built. So we're going to initialize cursum with 0, and maxsum with int min. Okay, let's go ahead and start implementing this as we go, right? So, int cursum equals 0, int maxsum equals integer.min value. I've legit never heard of this algorithm, but that's probably because I haven't studied DP enough. Now iterate over the array and add the value of the current element to cursum and check. If cursum is greater than maxsum, update maxsum equal to cursum. Cursum is less than 0, make cursum equal to 0. Really? Is that it? So, okay, let's try it. So for int I equals 0, I is less than nums.length. Great. So, wait, hold on. Okay, let's indent this stuff so it's actually at the right level. So we need to add the current value to cursum. Cursum plus equals nums at I max sum equals to the maximum of itself and cursum. And I think at the end we can just return cursum or return maxsum. Is that just it? Wrong answer. Okay. Okay, what am I missing from the algorithm here? I guess maybe we do need to do it to 0. See, because that works for this algorithm here. Okay, so why does that fix this is my question, right? Like, that fixes that, but why does this not fix that? Okay, yeah. I guess we can just add this as a little edge case. So if nums.length equals 1, I'm gonna run into more issues with this, I think. This whole negative, aspect I think is gonna be an issue. Yep, there we are. Okay, because we can't get negative results with ours. Why does that break it is my question, right? How are we even getting 17 is my question, right? So we take 10, that goes down, 5 plus negative 5 plus 5 plus 12 is 17, minus 100. I think I might be missing a step or two here. Yeah, okay. Okay, let's see the Java implementation, right? Yep. Yeah, but I don't understand why this doesn't work in our case here, is the thing. Maybe I need to do it here. Okay, that's interesting. So, as long as we update the value itself after, as long as we update the value of curval after, it is okay somehow? Let me run it again. Maybe it'll be faster this time. Is it? No, it's just that slow. Oh, I guess it's not that slow, huh? Okay. Number of k-length sublists with average of at least targets. So, this one's also prefix sum, and it's not helping me in the slightest because I'm terrible at prefix sum and not sure how to approach this. But what we're going to do is try and figure out sliding window or prefix sum. Wait a minute. So, given the list of integers in target, return the number of sublists whose length is k. Oh wait, the fixed length makes this easier. If it was like number of sublists in general, alright, so, gotta start a window. Start a window of size k. Then we remove first element and add next element. Find average, repeat. And that's really the algorithm for this one. The idea of prefix sum here, I'm not quite sure where to apply it, because sliding window just makes, I guess, a lot more sense to me in this one. That might also be just because I'm familiar and a lot more familiar with sliding window. Cool, let's go ahead and do that. So, first of all, we need to add up everything inside our initial window. So we're going to do int sum equals 0, int total averages equals 0, for int I equals 0, less than k. The thing is, we're not guaranteed, I think, that k is longer than numbers, so we might run into edge cases there, but I guess we'll see. This would be another good question to ask, because the problem statement doesn't say that k, because usually it would say like k is less than or equal to n, which is less than or equal to 100,000. So who knows? I guess we'll see if that crashes. Sum plus equals nums at I. Then we need to calculate the initial average. So if sum over k is greater than or equal to target, total averages plus plus. Then we need to repeat the steps. Gotta copy this loop, because we're going to be doing pretty much the same thing, except this time we're going to be starting at k. Ki less than nums.length So first of all, we're going to need to subtract that first value. In that first value, say k is equal to 3, we're going to add 1, 2, 3. We're going to start here, so minus k, 1, 2, 3. So sum minus equals nums at I minus k, like that. That's true. Because it would be an issue if it rounded up, I think. Okay, now we can make that same check as we did here. And I think we just return total averages. Nice. Yeah, once you realize that the lists are fixed to size k, it makes the question a lot easier to tackle. The more difficult version of this question, right, I think would be the number of sublists with an average of at least target. I think that's what would make this significantly more difficult. Interesting, okay. The usage of Codain's algorithm here was pretty interesting. I've never seen this algorithm before, but it's definitely it's a very simple one that I feel like I should have been able to come up with, but I wasn't, so. Very good, very nice one. I guess the thing that really kind of threw me off, yeah, it's an iterative dynamic programming. The thing that really threw me off about Codain's was the placement of the cur sum equals 0. Which, I guess that does make sense because if, what's it called? If you are in negatives, taking nothing is always better than having a negative number. So I guess that's why, in that case, you set it to 0, and you just kind of don't take anything. Gives you the biggest sum. You know, I did have to use a hint to get like a pointer to what the algorithm was, but I think that's okay. Well, now I've got 20 minutes. I'm not quite sure what to do with these 20 minutes. I guess the one thing I can kind of do is say they don't allow empty sums. That's a great question. Where, let's see, for this one, right? Turn the most sum of non-empty contiguous sublist with the largest sum. So, I guess that does raise the question, maybe their edge cases or their test cases didn't cover it, but like, what happens in the case where all of your, I guess if all of your sums are negative, so let's take a, for example, let's look at a test case that looks like this. If your test case looks like -1, -4, -3, -6, right? Our algorithm goes through, adds -1. -1 is going to be bigger regardless, so it updates the max sum to -1. Then, I think because adding any of these later on would have made it smaller, so we reset it to 0. We then take -4, don't update, set to 0. -3, don't update, set to that. So it does work in that case because if you're negative, you never want to. So if you're in the negatives and let's say we have two cases, right? We have this and we have this. Ooh, tab switching shortcut. So if you have these cases, if you're in case 1, adding a negative to a negative will always make it smaller, so it makes sense to set it to 0. If you have a positive value, starting from 0 and adding a positive will always net you a bigger sum than starting from a negative and adding that. So I guess this statement does make sense when you really consider the cases in which it would apply. Very interesting algorithm. Quite like it. Yeah, there is, let's see, what was I gonna show? Do I have? There it is. VS Code is open. So, I've been showing off the project. Yeah, watch this page video. The hint sent me down a rabbit hole. Very interesting, this algorithm. Okay. Alright. Yeah, we've been working on this like game project for, you know, who knows how long at this point. I think we're on week 7 of the project. So I'm gonna have to mute it because it's just gonna be terribly loud. I'm gonna not add in like the sound effects just because they're terribly loud. But yeah, the kind of newest update to it, we needed to demonstrate a minimum product yesterday. So we needed like menus and everything. So after a night of no sleep, we have menus. So you've got your menu, your normal mode and hardcore mode that you can choose from. I feel like this has it fits the arcade theme very well. And one of the biggest additions that we have now is we intended this game to be like sort of a speed run, like how fast can you beat the game, and start kind of competitions with our classmates or whoever else was willing to really try it. So we added a built-in timer now, because initially we had people pulling up like a Google timer or a timer off of their computer that they would run right next to it and record their runs for the game. But now having an inbuilt timer makes it to where that's no longer necessary. And once you get the controls down, it feels very sort of fluid to play. There are still some frame drops here and there, but that's who knows why. The stupid drill that constantly gets in the way, and still haven't figured out how to route around it, but we're intent on keeping it because it makes the game that much more difficult. Yeah, and then you got your boss. The thing about the hardcore mode of this game is that you have 1/3 of your usual health, and usually you can just kind of damage boost your way through this guy, because there's certain areas we figured out like this where you can stand and be invincible. Some of his attacks, if you get lucky, you don't get hit by. However, in hardcore mode, I think it took a good maybe day for somebody to actually beat it, because you having 1/3 of your health, you have to change the route pretty much entirely for how you play the game, because you cannot just damage boost your way through him anymore. He also just like shrinks, and that's his current death animation. And yeah, these are the kind of newly updated settings. But it's pretty neat. I mean, there's I think a lot of refactoring that needs to happen for these things. The player file, if I scroll down, the logic for the player and everything that's currently in it extends to about 1,400 lines of code just for the player. But I mean, granted, when you have such complex movement mechanics, it's all written just in JavaScript on an HTML canvas, which is, it's kind of surprising that you can get away with doing that much with just like a canvas element. But pretty much from the start, we were given a game engine that had a super basic like update loop, which would call every object in your game, call its update method, and then you would also have call the draw method of every object. And pretty much from there, we had to write everything from scratch. So a lot of what we did, we wrote from scratch. We made tons of modifications to have it do what we needed. We've got, tons of separate kind of classes and entities and whatnot. So everything you see here is pretty much from scratch, written in JavaScript, with definitely not stolen sprites from Capcom. But yeah, I think the dog by far is one of my favorite things, because the animation for it is just so smooth. When it teleports in and out, sits down. Yeah, it's you take a lot for granted when you don't have to build the game engine from scratch. Because I mean, even for example, wanting animations to, for example, instead of looping, stop at the last frame and then move on. Had to go in and write a method that would allow me to detect when that happens. Wanting these tiles. Initially, we set our game tiling to be 64 by 64. That's kind of what we decided on, and had to build around that. I still don't understand why there's certain places where my tiling system doesn't work. But like, instead of, nobody wanted to place hundreds of ground tiles by hand, and it would also up the entity count pretty significantly, so I had to spend like a night or two building out a ground building system. So if you turn on the debug settings, you can kind of see that each one of these kind of bigger ground tiles consists of just a few hitboxes, which allowed us to combine, like 200, 300 ground tiles into one entity that has its own collision, rather than, having 300 entities that all need to check their collision. Down here, you can see the total entity count that we have running, and currently for this level, we're at 93. If each of these ground tiles was its own thing, oh good grief, it'd be terrible. Starts to lag at like 200, 300 entities. Might be because we have a lot of late night caffeine-fueled spaghetti code. But overall, I mean, it's pretty interesting. I'm looking forward to, I think the next task that I've got is a level builder, which, hold on, let's see, online paint. Let's see, an online JS paint app, cool. So the idea behind this level building tool is currently the way our levels are built is every entity has its own import statement. So you do, engine.add, and then you give the type of the entity and its parameters, which is terribly slow. This first level, I kid you not, just the basic layout of it took me about 4 or 5 hours, because I had to place in every one of these by hand. I had to go through, figure out which coordinates it's supposed to be at and whatnot, and how long it should extend. Overall, terrible process. The idea with the game engine is to have an image that you pass in. Let's say you've got this. Then you can go into Paint, Photoshop, whatever image editing tool you like, and let's say you want to place in a ground tile here. You go in, you add a brown box. Let's say you also want to place in some ground tiles here. And you want to, let's say, place in like a platform here. Let's make this a bit more precise. There you go, close it off. And then you, let's say, want a player object to start here. You want your enemies to start, let's say, one here, a different kind of enemy here, and you get the idea. So the idea is to have this be what all you need to do to build a level, and then have a script. Who cares how terribly inefficient the script is, because it only needs to run once. And what this script is supposed to do is take your level, take your incredible artistic masterpiece, and convert this into a series of, okay, well, if you're going to give me the option to make a text object, let me add the text object. Is that what you want? Okay, convert this into a series of, let's say the player starts here, add player at like, I don't know, it looks like a 2, 0. You can import image and convert it to a level, pretty much. That's the goal. The other idea was to have it parse a 2D array of like, 0, 1, 0, 1, 3, whatever for different entity types. But I think this visually is a lot more appealing to work with rather than working with an array. Because let's say, oh, all of a sudden, I don't want this ground here. All I need to do is just take this and erase it. Now I have a, now I just have a hole. Rather than going into my 2D, massive 300 by 300 2D array, finding the spot that I want to work with and just changing all those ones to zeros. The most difficult part is going to be solving a lot of separate, separate problems, I think. Because, I mean, the thing is, because, again, we optimized it to have our tiles be, like, this is a really good, it's simple, easy way to set up. I hope so, because the most difficult thing is going to be, for example, let's say we have this overlapping corner here, right? Which block handles this portion? You know, is it this block that gets to take this portion and build it out, and this one needs to stop here? Or is it this block that needs to take this portion? Because overlapping it, you get inefficiencies. So it's going to be a fun problem to solve over the next couple days, but I'm genuinely kind of excited about it. I mean, pretty much what I'm planning on doing is these enemies going to be easy to implement. You literally just look at the pixel color, add a statement. I think depending on the size of your level, it will matter because the way that we handle collision is what really throws it off. Because if you notice, there's a lot of different colored boxes. We have left, right, up, and down collision boxes for these entities. I guess it doesn't matter how you cut it, it more so matters that they don't overlap. Because if these bounding boxes begin to overlap, our player's collision begins to spaz out. One of the biggest issues we had initially was people being able to find places like this and straight up just like teleport through the map, grab onto an object somewhere else, and just slide out because the boxes were overlapping, so that was something that needed to be fixed. However, as long as they don't overlap, I think it should be fine. Yeah, like if you notice here, we had to add spikes because people kept clipping through. So I think as long as they don't overlap, we should be fine. So I think my idea was to pretty much, the image, after it gets imported, still gets converted to pretty much a 2D array of pixels. And each pixel, I think as long as I take its hex code for the color, or if I get RGB and convert that RGB value to a hex code, I should pretty much end up with the 2D array that we were going to work with initially. However, rather than needing to modify the 2D array directly and then convert that to a level, all you need to do is draw something here, let the script convert that to a 2D array for you, and then convert that 2D array to a level. And I think if I can get this working, we can bring down the full level building time. Like this one, I kid you not, like, okay, the level itself was, 5 hours, whatever that happens, but all the little things, all the spikes, all the enemies, all the slight adjustments that are needed to make sure that it fits and works, probably a collective like 8 hours for this level. And the thing is, I think our current record speedrun is at like 1 minute and 2 seconds, which, I mean, you spend 8 hours building something for it to be beaten in 1 minute and 2 seconds. But yeah, that's going to be the thing I keep working on probably for most of today. Not like I really have any other projects to do with my current classes. But yeah, I guess for now, the time being, let's go ahead and go over the time and space complexities of these solutions. And it kicked me out of the room for idling, I think. Okay, so strictly increasing or decreasing. What I like about this solution, there is definitely an argument to be made about just checking in 2 separate for loops, but this cuts it down to 1 traversal. What I did was I pretty much kept track of assuming they're both increasing and decreasing, and at any point, if it's not increasing or if it's not decreasing, I set that value to false. And then basically if either one of these is true, we return true, otherwise false. This is done in O of 1 space and done in O of n time. Very quick, very simple solution. I don't know that there really is a faster way to solve it. It's a faster way to solve one. So, moving forward, we've got, what do we have? So this one, consecutive duplicates, we don't really care about explicitly removing duplicates from the string, though if we were really concerned about space, we could, I was gonna say maybe like put it into a string builder and then like concatenate it, but yeah. You think, oh, I mean, you make a fair point that you could potentially abort out of here early. So I guess what we can say here is if not is increasing and not is decreasing, return false. That might be the optimization it was looking for. Because I had the idea to do something similar, but I just never got around to it. Yeah, it's about the same speed. I think depending on a case, it might be faster if there's like a case where you have like an array that's like 0, 0, and then continues on for like 100,000 times or whatever. That would be a great case to do it. So consecutive duplicates, all we're really doing is looking for changes in characters. You can check the first two elements. Alright. Then you know what needs to happen in the rest of the elements. Oh, that's true. Because it can only satisfy one condition. Mind checks, yeah. I guess that makes sense as to why. Why it runs I mean, it makes sense to run at 50% because if you cut out the what's it called? If you cut out the other half that you're not supposed to be checking, it might be faster. But yeah, for this one, we are pretty much anytime we keep track of the current character. Anytime we see it changing, we know that everything before it was a duplicate. So we just add that new character and then update the current character and continue to repeat that process until we're all the way through the string. This is being done. I think the string builder either counts as a potentially O of n space or either an O of 1 space, one or the other. By time complexity wise, it's being done in O of n. Best time to buy and sell stocks. Because I pretty much use the same logic for both questions. Yeah, it's pretty, I could see how it's similar. Alright, so number 3. Given a list of integers, return the sum of the largest sum of a non-contiguous sublist. So this one was very, very interesting because both of these being DP really threw me off and it really scared me. So, what we ended up pretty much doing for this one is going out and actually learning about Codain's algorithm. So what I'm going to do, I think, is paste this here for the future. Make sure I submit it. Pretty much what Codain's algorithm does is, man, this solution is either 70 or like 90%. It's so all over the place. What Codain's algorithm does is pretty much keep track of the maximum sum that we can get at any point. And then we return the max sum because at the end, the max sum that we get is the max sum that we can get through the whole array. So we pretty much add what we currently have as our element in the array. We check to see if that's bigger than our max. If it is, we update it. If it's not, we leave it. And then this line right here, I think, is the one that's most important. If our current sum is less than 0, based off of these only two situations we can have, there's no situation where a negative starting sum is going to be better than a just 0 starting sum. So that's why we update it to 0. Very, very, very important line. This is being done in O of n time with O of 1 space, which is very, very fast for a DP problem. Like, I used to DP taking way more space than this. And last one is a sliding window approach, where we pretty much start calculating the sum of our window of size k. We then remove the first element, add the next element, and by doing so, we continually slide our window over, and every time we slide the window, we calculate the average. If it's the amount that we're looking for, we add it, and then we just return the total averages. Very simple, very quick solution. This is being done in O of n time with O of 1 space since we're just using variables, and even though we do have nested loops, it's still not 2n, it's just n, because this one goes from 0 to k minus 1, and this one goes from k to the end, so we only hit every element in the array once. And I think the beauty of the sliding window approach and what makes it so nice and so fast is that we could have done this with one loop, where every time we shift I over by 1, add k elements, I over by 1, add k elements. But keeping a current sum counter going allows us to just avoid having to do that at every step, and just subtract first, add next. And I think that's the kind of the beauty of the sliding window in this approach. But yeah, I think that's going to be it for me today. It's a very interesting session. Learned about a new algorithm, explained my incredible art skills to make a level builder, showed off a cool project with a very nice arcade feel that keeps tanking frame rates for some reason. Who knows why? Alright, that's going to be it. Thank you everyone for stopping by. Hopefully we all learned something. And I'll be back probably tomorrow, around 10:30ish PST. Take care.